If you printed the entire Earth onto a single grain of sand, the Sun would be a beach ball, and the nearest star after our Sun, another beach ball, 4,000 kilometers away. That's the scale of just our tiny corner of space. We haven't even left our own solar system yet. By the end of this video, your brain is going to break a little. That's a promise. Let's start small, because even small is bigger than you think. Light travels faster than anything in the universe, 300,000 kilometers every single second. In 1 second, light could circle the entire Earth more than 7 times. And yet, it still takes that light about 8 minutes to reach us from the Sun. From Pluto, sunlight takes over 5 hours to arrive. And Pluto is still technically our neighborhood, just one of several icy worlds drifting at the edge of our solar system. Now leave the solar system entirely. The nearest star to our Sun, Alpha Centauri, is 4.2 light-years away. That number sounds small until you convert it. 4.2 light-years is roughly 40 trillion kilometers. If you could drive there at highway speed, non-stop, never sleeping, never stopping for gas, it would take you over 50 million years. You would arrive long after humanity went extinct, or evolved into something else entirely, or simply forgot why the journey ever started. Even our fastest spacecraft, which has been traveling for nearly 50 years and has already left the solar system, would still take over 70,000 years to reach that same star. Distance in space doesn't just feel large, it actively mocks our fastest technology. Our Sun is one of roughly 200 to 400 billion stars in the Milky Way galaxy. If you tried to count them, 1 per second, never stopping, it would take you over 6,000 years. You would need to start counting before the pyramids of Egypt were built, and you still wouldn't be finished today. And our galaxy itself is about 100,000 light-years across. Light, the same light that crosses our solar system in hours, needs 100,000 years just to cross from one edge of the Milky Way to the other. And our galaxy is just one of an estimated 2 trillion galaxies in the observable universe. Not 2 trillion stars, 2 trillion entire galaxies, each one containing hundreds of billions of stars of its own. Multiply those numbers together, and the total number of stars in the observable universe is somewhere around 1 septillion, a 1 followed by 24 zeros. There are more stars out there than grains of sand on every beach and desert on Earth combined. Here's something strange about all this distance. When you look at a star, you're never seeing it as it is right now. You're seeing light that left it years ago, centuries ago, sometimes millions of years ago. Looking into deep space is the closest thing humans have ever built to literal time travel. Some of the galaxies you can see tonight stopped existing in their current form before complex life even appeared on Earth. The star might have already died. The light is still arriving anyway. The night sky isn't a snapshot of now. It's a layered photograph of the past, all stacked on top of each other. Each point of light showing you a different moment in history simultaneously. The light from the moon is about 1 second old when it reaches you. The light from the Sun is 8 minutes old. The light from Alpha Centauri is over 4 years old. The light from the most distant galaxies we can detect is over 13 billion years old, almost as old as the universe itself. Here's where it gets genuinely strange. The observable universe, everything we can possibly see in any direction, is about 93 billion light-years across. But the universe itself is only 13.8 billion years old. So how can we see something 93 billion light-years wide if light has only had 13.8 billion years to travel? The answer is that space itself has been expanding the entire time, stretching the distance between everything, even while the light was travelling toward us. Imagine an ant walking across a balloon while someone slowly inflates it. The ant is moving forward, but the surface beneath it is also stretching, carrying it farther than its own steps would suggest. Light has been doing exactly that for 13.8 billion years, walking forward while the universe expands beneath it. This also means there's a part of the universe we will never, ever be able to see. Not with better telescopes, not with more patience, not given any amount of time. Space is expanding so fast in some regions that light from those galaxies will never reach us. Not because they're too far away in the traditional sense, because the universe between us and them is growing faster than light can cross it. Those galaxies exist right now. We will simply never receive an invitation to see them. And the expansion is accelerating. Far into the future, even the galaxies we can currently see in our own cosmic neighborhood will stretch beyond our horizon, fading from view one by one, until some future observer might look up and see almost nothing at all, just their own galaxy, alone in an apparently empty universe, with no way of ever knowing how much more once existed. So, when you look up at the night sky, you're not just looking at stars. You're looking at ancient light from objects so far away that human language barely has functioning numbers for the distance. And somewhere in that unimaginable vastness, on a tiny grain of cosmic sand, orbiting an unremarkable star in an ordinary arm of an ordinary galaxy, you exist for one extraordinarily brief moment, capable of understanding just how big it all is, capable of measuring distances you will never personally travel, and comprehending timescales longer than your own species has existed. That might be the strangest part of this whole story. Not the size of the universe, but the fact that something as small as you managed to figure any of it out at all. If this broke your brain a little, good. That was the goal. Coming up next, we're going somewhere even stranger. Inside a black hole, where some of these same rules about space and time start to break down completely. Subscribe so you don't miss it. And if you want to help us keep making videos like this, we have a Patreon, link in the description, where members get early access and a say in what we explore next. I'm Cosmica. See you next time.